Ah, there we are. We're now streaming. I am super tired, as usual, when I'm streaming. I don't know, something about Wednesdays and Saturdays. I always seem to either get no sleep or wake up super early. But at least this time I didn't eat a spicy dish and a ton of candy just before sitting down. So, just tell the world, oh, looks like I'm making loud noises against the mic, too. Just adjust the mic a little bit. Streaming, game dev, I guess I'll work on Dust. So, as you might have noticed, I was just kind of playing around a little bit to try and get my hand on, trying to get I'm trying to get used to this engine, Unreal. So I've just been kind of doodling around, and one of the things we did is we kind of sort of started to make some kind of underwater sort of thing. Super primitive, super basic, super hiccupy. But we're going to just try and polish this just a little bit more, because I wanted to try some particle system stuff. Still not used to the particle systems in Unreal. And if there's anything that makes water feel like water, it's a bunch of junk. So we're going to create some kind of moat particle effect. But we're also going to take this light mass importance volume. I guess it doesn't matter because 90% of our lighting is faked. So we're going to ignore that for now. So instead we're going to start with the particles. They're not under visual effects? Well, I didn't think this was going to be difficult. Can I create a new one here? Is that what I have to do? Create a new Niagara effect here? I guess it's probably called Niagara or something, but I think that the thing is you can't just put it into the scene. It has to be like made. Yeah, see that? So I either create a new emitter from a template or I inherit from one I've already got. I guess we'll just create a new emitter from a template. I don't want hanging particles. This is perfect. Just take a quick look at what else we got. Yeah. Now, some of these particle effects, we'll call this moats. Some of these particle effects that they give you by default, I've looked at all of them in passing. Some of them are awful, but some of them are great. Shall we roll the dice and see what we get today? Just drop that into the game world. Boom. Where'd it go? Does it not get dropped into the game world? Is there something I have to do? Maybe there's something I have to do in order to put it into... Do I have to like convert it into a system or something? There was some kind of step like that, wasn't there? There was some kind of... Is this an effect type? No, it's an emitter. Oh, I have to create a system, don't I? Yeah, that's what it is. We'll just try it again. Just start over here. Oh, this one's not... That's interesting. And my neighbors just started the party, so if you can hear the funky backbeat, that's them having fun. I'm not sure what I'm doing here. Well, this one actually goes into the game world, at least. I'm not sure. Clearly there's some kind of setup that I'm not completely understanding here. But that's why I'm doing this. I'm going to try and get a handle on it, try and figure out what's normal, how things fit together in this wacky new environment that I'm not used to. So what we're going to do is presumably adjust the size of the emitters. It doesn't appear that there is an emitter size here available to just be tweaked, which is a shame because that means that chances are it's part of the template, which is a terrible way to do things. You don't want your emitter size to be part of the template, because what if I just need to customize it to the various parts of the level that I need to stick it in? It's obviously something should be click and drag. It should be like just a brush, a geometry brush, but I could change the size of the scale. Don't really know if that's going to do very much, but the question is, when I do that, does it increase the size of the motes, or does it just increase the size of the effect? Well, given that I don't see any giant motes, my guess is it just increases the size of the effect. Let's go ahead and take a look. Here it is, off screen where you can't see it. Here it is. So here's the motes 2 system, and here's the hanging particles. I believe this is it, like exactly. I believe this is literally the template, and I don't know whether or not I'm allowed to modify it. We'll find out. So if we take a look at these emitter properties, you can see how it's a 2-meter cube. I'm not sure why they decided to make it a 2-meter cube, but they did. Interesting choice of size. I would say that is literally the exact wrong size, but that's okay. That's something I can work with. So the emitter spawn is nothing. The emitter update, loop duration 2, spawn rate 50. So if I were to change this from 50 to 500, in theory I would see more dots. Yeah, see that? That's a lot more dots. Now in Unity I had a much more complicated set of particles. Yeah, so these don't appear to be giant dots, so I think that this is more or less right. But what I would do in Unity is I would create the particles using my own custom particle creation script. And I would use that not just to create floating motes, but also to do things like lay down rocks. Don't think I'm going to be doing that here. I think that they're probably going to be some barriers to try, to doing that. But it doesn't look like this is anywhere near enough. So you see how dense this looks? But the thing is, I'm scaling it up rather a lot. What I really want to do is, and you see that it's looping every 2 seconds, or every 2. It says loop duration 2. Okay, so this demo here is resetting the particles, but it clearly says it doesn't reset the particles in the actual game. Okay. So it should be spawning in a ton of motes. You can see that they're orange highlighted, and they are fading away properly rather than just vanishing. And that's what I wanted to be clear about. Now the problem here is that in order to create enough motes to work, we would need a lot of motes. We would need to fill the world with motes. And that's just too many motes. So generally what you do in these sorts of situations is that you only fill the part of the world that's near the player with motes. And the way you do that is you attach the system to the player instead of the world. So to do that, we need to find the player. There he is. Just pop that open. Now in theory, we should just be able to add the motes in, but Unreal has been finicky about this in the past, and I'm not sure whether or not Unreal understands this kind of thing. It might barf. Oh, it didn't barf. Hooray! All right. So we'll go ahead and just add that in and just take a look, take a quick little peek. I have a feeling that we're going to need to adjust it just a little bit. Yeah, so you can see that, good, it's in world space. See, that was one of the risks. If it wasn't in world space, then I would have had to figure out a way to make it in world space, because obviously I don't want the motes coming with us when we move. Another problem we've got is that the motes are transparent, which means that they don't count as near the screen. If you take a look at the way that they don't exist in this foggy area, you can see exactly what I mean. And also over here, they are fading out with the rock background rather than appearing to be floating directly in front of us. Now that's not a big problem as long as the motes are not very significant. If the motes are quite small and uninteresting, it doesn't really matter if some of them vanish or become invisible. Yeah, exactly, Mifaz. It's not passing the z-test. But the reason for that is simply because the motes are a transparent object, so they're being fired on the transparency layer, which the shader is ignoring, or the transparency pass. So in order for this to work, I would probably need to either change the shader I'm using to be post-transparency, because right now I'm not really sure. I think I might have to do 2 passes if I do that, or just, another extra pass. But another option is to just make the particles opaque, which is what I did in Unity. There's not really any big reason for these particles to have any transparency to them. They should really be an alpha test opaque. So let's go ahead and see whether or not we can figure out how to make that happen in Unreal. Here they are. If we take a look, color mode, position mode, sprite attributes, sprite size, sprite UV mode, mesh scale mode, sprite point attributes. None of these are about the material in use. So where is the material specified? Sprite. I mean, it should be here, right? But it's not. Sprite renderer, here it is. So here's the sprite renderer, and let's take a look. We've got facing mode, face camera, all of this stuff is fine. All we want to do is switch it to alpha test rather than transparency. That doesn't look like an alpha test. All right, so this is clearly at least something like what we want. Let's just take a look. Source mode, emitter, particles. That's not important. So here's the default sprite material. I guess we probably can't select that. My guess is that it is. Oh, it actually exists? Okay, well, hold on. Let's take a look. Mifa says, clear the screen with depth equals 0. It looks like it's depth equals 1 currently. So I don't think it has anything to do with the screen being clear or not. This is a problem that is universal in the modern pipeline. Transparent objects do not set the depth buffer. So you can't tell how deep in the world something is if it's transparent. And the fog effect I'm using uses the depth buffer. So the particles are effectively invisible to it, which is why they don't render correctly. It's not a huge issue. It's just one that I want to... Wait, if I duplicate it, it becomes like a copy rather than... Well, we'll try it. So the problem here is I think I'm going to be adjusting the core of the sprite material if I do this, but small problems. So if we take a look, we got an unlit shading model, additive blend mode. We want it to make it masked would be the correct term. I see that the words are just a little bit different than they are in Unity, so I'm still struggling to get it to work. The particles in Unity are also a tremendous mess. There's something about particles that the game engines haven't really figured out how to make easy. Like, the particles are always a tremendous mess in game engines, and I don't really know why. I mean, there's a lot of stuff there, but it's not any harder than the rendering pipeline. Whatever. So I've just changed this sprite material, and you can see that it's now a weird box shape. And that's just because I've made it opaque, and we're going to see that pretty clearly when I change our objects to it. The question is whether or not they're already changed. And nope. So they're still using the old renderer, which is good because it means the copy was a shallow copy and not a deep copy, which means I can switch it over in the material editor. Let's go ahead and move the sprite material. That was not what I wanted to do. Gotta drag it somewhere, but I don't... Oh, that's right. In order to do this, I need to pop open the second content browser. Go in here and drop it over here. There we go. So then we just open up motes here, and we say, you're not the default sprite material, you're sprite 2. Oh, why did that not... sprite mat 2, my bad. All right, so you can see that they're now squares. We can deal with that later. It's not a big deal. So we'll just compile that and take a look and see whether or not it fixed our depth problem. Yep, see? Now you can see that the particles are now appearing in space rather than vanishing into the mist. Now, of course, the problem with this is that these particles are a massive, weird, bright splot that makes no sense. There are a couple of reasons for that. One is that they're unlit. Another is that they're very large. And the third is that there's no texture attached to them. And there is technically a texture here in Sprite Mat 2. No, there's not. Okay, so this is just using a flat sphere mask to get the opacity. Well, that's fine. We'll just sploop that over into there. So I thought we were using like a soft circular color, like just a texture, but in fact it's just a mathematical sphere, which is fine. It also means that you can get real close and it won't pixelate, which is nice, except for we're not going to let the player get that close. We are in fact going to fade them out if the player gets that close. We'll work on that later. So you might be thinking this is way too many motes and they're definitely way too big. You are correct. This was just to make sure that we knew what we were doing. We are going to start to back it off right now. I'm going to start to make it a little bit better. So one of the things we do is we actually want it to be more in front of the player, and we're going to need to change the size rather significantly. So over here in motes, this is the object that we've put into the player model, and we're going to change the size of the emitter. I think we'll just double it, but I kind of wish there was an easy way to double it. This is like going to go through and type -200 a million times. But we don't actually want to double it flat. We'll get to that in a second here. So this doubles it, but the thing that we actually want to do is we need to make it flat, but long. So on one of these, we need quite a bit of depth. Is it this one? It might be this one. Actually, it should be like just positive depth. So if we compile that, and then save it, and then go over to the first-person character and take a look. So you can see that what we've got is... That's not right. Did it not update? Oh, look, it's supposed to be substantially larger on one particular axis, but this looks, if anything, like a square that's flat. Look at that. It's a perfect square that's flat. Did I misunderstand what the bounds were? What's going on here? Why is this a box? My guess is it's not properly updating from the motes 2 system here. Maybe I have to recompile it? No, that's the same. All right, well, we'll go ahead and try a couple more things. Right now we are emitting a massive amount of particles, and we need to bring that way, way down. Let's go ahead and try that. Okay, so it's definitely inheriting properly, But for some reason, the size of the emitter isn't properly changing. Which, I mean, I can just stretch it here. I can just apply a scaling factor, but it should just work, right? Okay, so it wasn't using these values before? Why was it a weird flat square then? Well, let's go over into the person and see what happens. It doesn't look like it's any different. It looks the exact same to me. Well, let's stretch it. So I don't know which axis is which. We'll try X, because X is usually red. Oh, well, thank you. Yeah, that's correct. And then we'll just move this so that it's kind of floating in front of the player like this. And now really what we needed to do is insert it into the camera so it follows the camera around. But that's okay, because at the moment, we should put it inside the camera. We'll just drop it in. Poof, there we go. So that way it'll always remain directly in front of the camera. Since the capsule component might not tilt, the camera will. So now when we hit play, you can see that we get these motes. They kind of pop into existence super fast. Obviously, we'll need to adjust that. We'll need to make that a little bit less cluttery. And the way to do that is to, well, a combination of things. One of the things we need to do is to reduce the brightness and size of these motes. Now, obviously, we're always going to have a problem with motes near the camera, which is why, in general, you make those motes go away. I don't really know how to do that. I don't know if the Niagara system has an exclusion zone capability. In Unity, you can make a box, a collider, that if any of the particles are inside that zone, they just go away. I don't think that's possible here. There are a lot of ways to kind of get around that, but they're all a little bit kludgy. Not really sure that I want that. Let's take a look. So if I were to add an emitter, okay, well, that's just a whole bunch of emitters. Here's clear isolated emitters. Zoom to fit, zoom to all. System attributes. Okay, so these are all just the things that are already in here. There doesn't appear to be a method of adding non-emitters, like, you know, kill zones. But it could be that inside of the emitters, there is some kind of kill zone system that's possible to make. I just don't know exactly where that would be. Emitter update, add a new module. New scratch pad, utility, emitter frame counter, spawning, spawn per frame, spawn rate. I want the opposite of spawning. Spawn MS vertex animation tools, morph target. That's exactly what I want. Particles in grid, emitter state, particles from other emitter, spawn from chaos, beam emitter, and audio. So there is no emitter update state for destroy these things if they are in a particular spot. So let's take a look. If we add a new particle spawn, oh, there's a lot more options. Let's just walk through them. Velocity. Add velocity. That could be fun, because I could make it so that when you swim through them, they kind of fly away from you. Vector field. I don't know how to get a vector field, but that would be fun too. Place particles on a rectangle. Sample pseudo volume. Place particles on depth buffer BTU or GPU. Oh, hey, that's interesting. Maybe I didn't need to make them opaque. Maybe this would have worked. Don't know. Interesting things to keep in mind for later. Find kinetic and potential energy. Flight, initial mesh, orient to mesh, pure roll. Cone mask. Ooh. That might be pretty good. Fade over time. Some of those are pretty good. Spawn particles in these. See, I actually want to do the opposite. I want to despawn them. Kill. Kill particles in volume. So if we kill particles in volume, we can kill them near the head of the player. All we really have to do is figure out where the heck this volume is and how big it is. I can't really tell where the volume is here in... Is it this right here? Is that what it is? So the origin offset, we're going to go ahead and make that negative 100. Now if we invert it, we should see a circle. Yeah, there it is. See it? So I was not oriented the way I thought I was. So if we invert it again, we should now see a missing little gap. It's hard to see a gap, right? But that's more or less correct. So we're going to go ahead and compile that and save it. But the problem is I'm not really sure where that gap is here. We're going to have to, you know what we should do? We should invert it. And then use that existing ball on the camera. So negative 100 is clearly not enough. We're going to bring that back to negative 300. So there it is. And all we need to do is center that in front of the camera. Perfect. Come over here, invert it again, and compile it, save it. And that should get rid of the motes that are super close to our face. Now we're just going to compile and save here. Hit play. It's not getting rid of shit. Oh, okay, so it is. It is. Some of these are going away. Maybe it's because the volume isn't in front of the camera enough. Okay, we'll just move it a little bit, see whether we can tweak it to be a little bit further in front of the camera. Drive towards the moat, and it's not vanishing. You see, the whole point of this was to make the motes that were in front of the camera disappear. And what I was going to do is, if I can make them disappear, that's fine. But what I really want to do is make them move. Let's go ahead and try to figure out if I can make that volume do something a little bit more interesting. All right, so let's destroy this kill volume right for a second here. Up in update, there was the ability to add a some kind of push. Was it an update? It might have been. I mean, this is in emitter update, right? Oh, particle update. Okay. Of course, particle update is different from emitter update. That was what was confusing me. Now I've got it. So we're going to look for a way to add a push to things that are inside of a specific box. Add velocity in cone. That would be fine if I can designate exactly how big the cone is. Add velocity from point. Again, that would be fine as long as I can designate how far, how far that drop off goes. Let's try point. Okay. So it was just in the wrong order. That's fine. So basically, if we velocity, strength, origin, offset, origin and coordinate space. So it doesn't look like we have the ability to limit the point to a specific range. So that meant that we were emitting, we were just moving all points away from that point in space at all times, which is not really what we wanted. So we're going to try again. We've got a vector field. See, I could do it with a vector field, but I don't know how to get a vector field. It makes more sense for us to do it using some kind of bounding box. There's probably another option. Let's see here. See, the problem here is that there is no ability for us to limit this cone to a specific size. So it's useless. We don't want to drive all particles that you're looking at away. We just want to get rid of the ones that are in front of your face. Maintain a set distance, pendulum constraint, debug, default, distance fields, events, export, forces, avoid cone. If it wasn't a cone, it would be perfect. If I could avoid sphere, well, I think that I could add the kill particles in volume here. Before, I think I added it in particle spawn, and I think that's why it wasn't working, because it was just preventing the particles from spawning near the camera. It wasn't actively deleting them when they came near the camera. But I really want to push them away. I don't know. Why is this in particle update, right? This should be in particle spawn. I can spawn more particles in particle update. That would create like a recursive loop where every particle spawns more particles. Is that what would go on there? Not brilliant. Not brilliant. Basically, I want a particle update chunk that is only applied within a specific bounding box. I just don't know how to do that. Let me go ahead and see whether I can get Unreal Particle Niagara update push out of bounding box, bounding collider. Call it collider. So they say to use like literal collisions rather than a virtual box, which you would do inside of a collision query. Collision query, huh? Let's take a look here. I don't know exactly how this works. There is no collision query here. Generate collision event. See, they're showing me something that's different from what I'm seeing here. The version on their website has the particle update, but then inside of the particle update, oh, they're showing me this side. Okay, they're over here, not over here. That's different. That's fine. But there is no collision query thing. This is just a standard old collision. This looks complicated. I'm not sure whether or not this is going to be cheap enough to actually do anything. Problem is that the player has a collision box. It's kind of in front of the camera, but it's not that in front of the camera. The camera is simulating your head, whereas the collision box is simulating your body. So it's not, they're not really related. I don't have the ability to tell this which kind of collisions to... Oh, here it is. I don't know whether or not that's going to work. I don't think it is, but let's try it. What's the worst that could happen? I could crash the computer. Everything could explode and burn down. Okay, so here we are looking at our particles, and then it doesn't appear that... I mean, it might. No, that particle is... So the collider is... I would need to make a collider around the camera. That would be a specific kind of collider, specifically for getting rid of particles. Oh, sure, why not? Let's go ahead and do it. Let's create a push force collider that all it does is collide with particles. So not the idealist of ways to do things, but maybe it'll work okay. Well, let's find out. So to do that, we are going to just create another collider inside of this capsule collider. Add component, sphere collider. And we'll call this the particle pusher, or we'll call this what? The wake? We'll call it the wake. And basically the wake is going to be a larger sphere. So we want overlap all. What's the difference between overlap all and overlap all dynamic? I don't know. But what we really need to do is make it custom, right? And then change this to... this isn't quite right. So let's take a look at the particles one more time here. When we're telling it what to collide with, we have this CPU collision trace, right? We got world static, world dynamic, pond, visibility, camera, physics body. So camera isn't one of the ones that we had the ability to choose. For now, let's just choose projectile. Why not? And then over here, we can set this to projectile. So camera must be a reserved one, right? So we're going to just ignore all of these. Oh, there's camera. I don't know. Okay, I'm screwing this up, aren't I? What is this? What kind of object does this count as? I don't even know whether this is at all correct. Ray trace collisions, does that require me to be in ray trace mode? So the CPU collision trace channel, I believe that what we need to do is just collide with that channel here. So if we were to change this to, I guess projectile is fine. And then we come over here, we can say, yeah, let's overlap with projectiles. In theory, that would fire, right? We're going to find out in a second here. First, I have to change the size of this sphere. It is way too small. There we are. So now that we have a sphere in there, we should be able to collide with it but I'm not at all sure whether or not that's going to work. It doesn't appear to be working, given the fact that this is not doing any sort of deleting of the particles within the sphere as far as I can tell. But maybe that's because we haven't compiled this. I mean, it's not working. I don't want to do it with collisions, though. I want to do it with just an arbitrary circle. All right, time to roll that back. I don't think that's going to work out for us. I think I might not understand the collisions as well as I need to in order to do this. So let's try some other approach. Just keep going through, see if we can figure out something going on here. What's a pendulum constraint? Yeah, that's not important here. So here's a location event. All that does is spam an event. Okay, so I don't have anything set up for that. I could set up an event handler, I suppose. I don't know what this means. Presumably this is to this is just to interact with like literal C++ code. Here's a render. So I could create, so one of the things I could do is I could make these things change color when they're near the camera, but I couldn't really, I might be able to make them change size, but I have to do it early. I could change their opacity to reduce their size when they're close to the screen. Let's go ahead and try that. It might be the easiest solution. So if we take a look at what we've got here, we've got these particles floating around. And what we've got here is the material that sets those particles up. One of the things they're doing here is this sphere mask. This sphere mask we can adjust B, which is, I believe, the radius. It doesn't actually say that B is the radius. Oh, here. This is labeled radius. I'm just an idiot. C. C is the radius. And we can replace this radius with a value that can be based on distance from the screen. So to do that, we're going to add a distance from the screen, different distance from the camera node. But I don't remember what that's called. Depth fade will do. So basically, we want the opacity default and the fade distance. We want this to be like 100 is 1 meter, right? Yeah, so that's fine. Is this fading out or fading in? I think it's fading out. So what we want to do is a 1 minus here. And that will allow us to have a radius that is based on the distance from only transparent or post-process. Okay, that's interesting. So this won't work. Let's see if I can find another source of depth. Depth from world position. Scene depth. This doesn't seem right. Sample scene depth? No, that's definitely not it. I mean, yeah, well, this might be good. Let's try this. So this doesn't need the inverter. It's already inverted. So we'll just send it straight over. And basically, we need to actually pass it fade length, fade offset, and 4 vertex shader. Because the defaults are... maybe those defaults will work out. We'll find out in a second here. It is built specifically to do this. Alright, so that didn't kill anything, and we can see by looking at the window over here that it's clearly doing something, but I think it might be doing the exact opposite of what we want. Let's find out here. Hit play, and a whole bunch of particles. Oh, none of them appear to be very close. Look at that. So this is definitely working. It's shrinking them radically when they're near the camera, which is what I need it to do. So, hey, go us. It might be a little bit aggressive, but that's okay. We can modify it later. So that's fine. Works great. We'll leave it like that. Hooray. Go us. So that will do. That will do. But one of the other problems we've got is that this particle color is just terrible. It's like flat white. The thing is that this particle color is part of the mote's emitter. It's not part of the sprite material. We're actually passing it the color somewhere in this mess. Here it is. So if we take this color and we make it into like a neutral blue, because it's unlit, and if it's white, I mean, that works if it's tiny and, you know, inconsequential, and maybe that's what we'll go with. But as you can see, neutraling it down a little bit really reduces the exaggerated brightness of it. So at least I think it's bluer now. I'm almost positive. I suppose we should double check before I just make an assumption. Let's make it super super pink. Okay, so now it is super pink, right? Yes. So we can put it back to being blue now. So with that in mind, we're still firing off too many. Let's go ahead and reduce the number of these getting emitted. It's fine when it's like, even lower maybe. It's fine when it's like part of the scene and you want to fill an actual space with them. But we're just trying to fill the player's eyes with them. So a large number isn't required. Even this is too many. And we can always polish this later. We're just doing this as a test. We're doing this to kind of set up how it should feel a little bit better. We're going to want to have some static ones as well, because obviously this only follows our camera around. So as we move, we see more motes in the area. It's a really cheap solution, but it also means that things that are in the distance, like say this nook here, which should be full of particles, isn't full of particles because there's no particle effect actually there. And we would, you know, create a different particle system for that. So, you know, we'll figure out what we want to do with that sort of stuff later, I guess. I just wanted to get more familiar with the particle system, and I'm definitely more familiar with it, but the collisions are still throwing me. I don't know how that works yet. All right, how long has it been? I'm super tired, so I'm thinking about. Oh, it hasn't even been an hour. I'll stream for a little bit longer than this. Thinking about like lots of stuff because I did this for like a year, right? In Unity, I created a diving game for like a year, and There are lots of things to consider when you're creating a diving game, like, for example, the surface of the water and how you're going to simulate that and stuff like that. And Unreal has a bunch of water sim stuff, but it is all like from above, not from below. But that's all stuff that we can deal with whenever, if we ever do. This isn't even really a project. It's just me farting around for kicks. So I'm not really sure what to do next. The thing that I was discussing, I'll look at that chatter from the Z fighting from just dragging rocks around. The thing that that I was thinking about, the thing that I've been considering when it comes to diving games is the mechanics of the diving game, like what makes a diving game fun. And I've got some ideas about that, but I don't know if I actually want to develop another diving game. I'm pretty burned out on diving. I just wanted to do this because I felt it would be a fun experiment. Now, what I don't get is why we can't fit in here. Let's take a look. Why can't we fit in there? What's wrong with the player model here? Where is the player model? That's got to be him. I mean, that's where the dots are. Is it called someone else? There you are. All right, so this is the character. Where is the collider? Is the collider not rendered? Well, that's unfortunate, because I'm thinking what might be happening is that the collider... No, this has actually got a radius. Even though I told it to have a radius of 0, the radius popped up to 34. And my thinking is that maybe that's what's going on? No, it's not. There's something else happening here. Oh, you know what it is? I bet these rocks have bad... Yeah, I bet these rocks have bad colliders, because I never bothered to define them. So my bet is that it just kind of threw together a random set of convex colliders and didn't bother to actually make them fit. Yeah, you can see that. That's probably the wrong collider. If we were to select them, we could probably go in and edit them. How do I go up? All assets. I don't want all assets. I just want to go up. How do I go to the default directory? Why is this... Fine there. Here they are. Just pop them open here. And if we take a look, I believe that this project is new enough that we're going with the project default collision complexity, which is probably not correct. We're just going to switch this over to use complex as simple manually. Later on, we'll maybe change the project itself, and I'll just do that for all of these rocks. All right. So now let's see whether or not that weird problem is gone. Yeah, that was it. All right. So now everything is fine again. Well, as fine as things can be. So in the Unity version of the diving game I was creating, it was a third-person diving game where you would stare at your own butt most of the time. And I was doing that for a reason, because I wanted to enhance the feeling of being a diver. But if I was going to do it here in Unreal, I would make it first person for a bunch of reasons. But one of those reasons is the fact that the mechanics that I would be adding would make more sense in a first-person game rather than a third-person game. Those mechanics being things like strict breath limits. If you've got a strict breath limit, then you need to know exactly where you are relative to the surface or to wherever you're getting your breath. So if you're in a third-person mode and you're trying to go towards the surface, you probably can't really tell how close you are. And your camera is probably not looking at the surface properly, so it makes more sense for it to be first person. But the strict breath limits and stuff, those are mechanics I want to explore. So that's kind of why I'm thinking about making some simple little diving game. I want to explore some of those mechanics because they're not properly explored. But, of course, a simple little diving game would have to be big enough to explore those mechanics, which would be not so simple. It would be pretty big. It would have to be, because the mechanics are partially about that. This water is so gray, and the reason for that is because the fog is gray, right? Maybe. Let's find out. So the material, sorry, not the material, yeah, it is a material. The material we're using for the post fog here, this should be it, I think. Yeah, we're going to delete the scene view material. We don't need it anymore. Here it is. What it does is at the middle distance, it will, so there are two colors we need to use, right? Right now we're only using fog color, which you can see down there in the middle. It's that kind of bluish gray. But in the middle distance, what we do is we use the standard color of the flat albedo of whatever we're looking at, which in this case is gray rocks. We need to actually be able to customize that as well. So that's what we're going to do. We're just going to copy fog color, paste it, name it ambient color. And we'll make it bluer like that, just for now. And the ambient color, what we're going to do is we're going to take sorry, I'm looking at the possibilities here. So this is the actual scene color, like with lighting and everything. And so we take the actual scene color and we break it out and we make it into a float 3. I think we're going to want to clean this up substantially. It's a little bit hard to read, and I knew it was going to be because I was playing silly games. So what we're going to do is we are going to split this into 2 separate nodes so that we can, you know, have a nice clean setup, right? I'll just move these out of the way here. Lit final version, and that's what we see when we're up close. When we're up close, we see the actual lit version. At the long distance, we just see the fog color. Here it is, fog color. I don't know whether or not, if I duplicate the fog color and leave it named fog color, is it going to be the same material? Is it going to be the same value in both? Like if I make this super red. Okay, so if I have it named the same thing in both spaces, it's the same value. And that's what I needed to know. So we're going to go ahead and just use 2 separate fog color variables to clean this up. So now that we've got that, what we need to do is just do a little bit more. Come on, just move. There we are. All right, so the last thing we need to do is clean up this middle distance. So the middle distance involves taking the ambient occlusion and the flat albedo, the unlit albedo. We multiply those together, and we actually need to multiply them again by our ambient color. And can I add another pin? No, okay, so this multiply unfortunately does not allow for infinite pins, so we'll create 2 multiplies here. And there we are. Perfect. Error. Of course, it's an error. So the error here is that we are once again getting this problem. And so we're just going to copy those, bring them over here, and do it. I really think there's a better way to do this. This cannot be the way that it was intended to work, because it is trashy. Oh, it sounds like I have a problem where it's actually in the wrong area. Let's move these over here instead. This will go straight to here, and this will go in here, and then here. You would think there would be a better way to get that, right? Cannot cast from float 3 to... So this is a float 3. Okay, so this is a float 3. This would be the float 4 then. Okay, that's fine. Exciting stuff. It should just auto-cast with a warning. I don't know why it makes such a big deal about converting from float 3 to float 4 and vice versa. It should just cast to float 4 every single time. That's just fucking obvious. But whatever. And then, of course, when you get the final result, if the final result needs to be cast to float 3, then sure, you pass the float 3 at the very end. But if there's some conflict and you're not sure whether a float 3 and a float 4 should be multiplied together as a float 3 or a float 4, it doesn't matter. Just cast it to a float 4. Or, you know, you could cast it to a float 3, but a float 4 makes more sense. All right, so now that we've got the color of this getting set up properly, let's take a look. Let's see whether or not we are still super gray. Oh no, now we're quite blue, as you can see. La-ba-dee, la-ba-di, la-ba-dee, la-ba-di. So this is a much more aggressive fog than we were using before, and that's because we've introduced another kind of fog. We've introduced a color that gets applied to our mid-range albedo at all times. And what we should really do is cast that color as the fog color for our mid-ranges. So let's try that. So basically, we see here we did this whole thing. We're going to undo it and just do this. And I guess we can just go straight here. Delete these. Delete this. Compile. Okay. So basically what we've done is we've made it so that the fog has two colors. It has a medium range color and a long range color. And the medium range color can be used mostly for color grade repair to make it feel like we're underwater. So to that end, let's go ahead and pump up that ambient color to be really, really blue. Yeah, so you can see that this is quite blue now. It's probably too blue, but I just wanted to make sure that I had that working. Obviously, you could create a different version of this for, you know, caves and stuff, because this is clearly us going out into some brightly lit areas. The water is not the right color. That's not the right color yet, but it's clearly us going out into the sun, right? Even though there's nothing over there. It's just, there's enough sun that even though there's nothing over there, the water is filled with sunlight. Now, if we were to take this fog effect and just make it flat gray, let's just blast a gray fog. The question is, how does that interact with a strong color grade in the short run? And I think that this is not a bad idea. I think that the idea here is that things are blue in the close areas, and then as you get further away, it gets just blown out, and the sunlight just becomes the main thing you see. I think that feels much better. And of course, if we were in a cave or something, we might pitch to black. And this is a really good little example of what we're trying to do here, because if we pitch to black before, then the middle term would also be pitching to black, and we would be unable to see medium term ranges. Now that we have two different colors, we can pitch to black on the long run and pitch to like a somber dark blue in the short run. Let's go ahead and do it. So let's rename post fog to sun fog, or fog sun. And then we'll just duplicate this. The problem is I don't remember. I had problems with this before. I'll call this fog cave. I've had problems where changing the values here in fog cave would change the values over there in fog sun. I'm not sure if that's going to happen here. We're going to find out right now. So the fog color is now absolutely pitch black. We're going to save that. We're going to look at fog sun. It's still white. Okay, so I don't know what I did to get it to behave wrong the first time, but oof, it really was behaving weirdly and very confusingly. Still, all we have to do now is find our post-process volume value, switch it from fog sun to fog cave. There we go. And you can see that the blue we've got is obviously incorrect. This blue here is just dumb. It makes no sense. So we're going to darken that way down and make it more of a purple. And now we have, oh, it's very purple. Let's back off on that purple just a little bit there. Just desaturate that purple. Purple is a much more noisy color, especially against black, than blue is against white. So it's still pretty purple. That's fine. We can deal with it. So here you can see the sort of visual we get when we are using, you know, cave depths instead. It's not as good, though. And one of the reasons it's not as good is simply that that cliff is really sharp. You see that? It's like it just comes out of the darkness and suddenly it's vivid pink. And the reason for that is because of that 0.5 limit that we've created. We'd probably need to polish this a little bit more, but let's try to just tweak this with a darker ambient color. So basically it's an almost black to a black, and let's see how that feels. Because remember that won't affect the lighting. Like if it's lit, then you'll still see it lit. Oh, you know what? You know what we're getting here? I see what we're getting. So the middle term fog that we are seeing, the mid-distance fog, see how it's gray for much of it, and then it slowly turns pink as we get further away, or purple? That's because we're applying it at the same rate that we normally apply fog. And what we should be doing is lerping between the two. All right, no problem. So unfortunately, these materials are not compatible. So if we change one, it's not going to change the other. But we'll go ahead and try it. We'll go ahead and just make it in here. We can always cut and paste later. So this, see this, we're lerping the alpha based on the square root of depth fade, which is not really what we want anymore. What we need to do is lerp here. And the alpha would be twice this instead of square rooting it. There we are. Delete this. This will produce a color that is more in line with what we want. And then we can lerp here. It's not going to work very well, though. Because the amount we lerp is the problem. What we actually want to do is multiply. I guess that's what we want. Let's go ahead and multiply instead. This is just like a test material, so we don't really care if we screw it up. This is going to darken things way down, though. Yeah, look how pitch black this is now. And that's because we are now multiplying rather than fading between the two, which means that something we were applying at like 0.3, 0.4, we're now applying at 1. And we can fix this by simply rolling way, way back on the ambient color. And maybe even changing that multiply. It might be a multiply and then a square. That might make sense. I'm trying to think if that would make sense. Anyway, let's brighten this up. Bright. It's a little bit purple. All right, so we're now lerping between this rather bright gray and black, and it's really coming off as dark. And I think that's mostly a matter of how quickly we're lerping over into the black color, this fog color here. Let's see how it looks if we just do it straight rather than multiplying it by 2. Now, the thing I'm trying to get rid of is that sudden changeover where it just becomes black. But I don't think we have to worry about that as much as I might say we do. Yeah. So this is how it looks without that extra black lerping. It's still quite dark, but it is much more readable, and we have some kind of sunlight going on here, which obviously is silly in a cave, so let's turn it off. Here's our directional light. We'll just drop that down to 0 lux and rebuild all of our lighting. That shouldn't have had to. That is not something that required us to rebuild the lighting. That was always set as movable. Is the lighting build complete? There. So as we look around here, you can see that we can see these surfaces. And yes, we do have a headlamp stapled to our skin in case you're not sure why these rocks start to glow as we approach them. For some reason, we've attached it to our neck rather than our forehead, which is easy enough to fix, right? It's just open up the first-person character. Find the rect light and move it into a position that makes a little more sense. And also put it inside the camera. There we are. Save that. Now our rect light will make a little bit more sense, visually speaking. Yeah, I mean, there are other ways to do this. I'm just trying to get the right feel for feeling dark and oppressive and foggy without feeling too PS1. I don't want to make it feel too PS1, you know? It might require some more work. We'll have to figure out how we want to do it. But the fact that we're going to be obscuring all this shit with particle dust if we go any further anyway is a big factor. We'll have to think about it. Either way, I'm going to stop now. See you folks in a while if you want to come back and see me do more shit later. Otherwise, I won't. Bye.